Today we'll be looking at the beginning of logarithms, which is just another way of saying what power. So we're going to replace what power with just the logarithm and just how you write this and all different parts and things like that, and converting it back and forth between the exponential form, that's right here, and the logarithmic form, that's right here. So once we get into the logarithm form, we can start doing a bunch of rules starting tomorrow with adding, subtracting, multiplying, dividing, but that we can't do when it's in exponential form. So that's the need for it. It's because there's a whole set of math rules that you are probably familiar with from last year that you've already done. So keep that in mind. And some of the problems in the book are going to be a little tricky. They make you think a little more. So it's going to be a step above from what you've done before. Even though this is the concept review, it's still going to be a little challenging at the honors level, of course. Okay, so first we could just practice a little bit and just remind ourselves that the answer is the exponent for a logarithm problem. So it always equals an exponent that you would find normally the little number above some base, right? And the base is now this little number. So it's like the base and the exponent switch from which one's small and big, right? So over here, the exponent is small, that becomes the regular size in the logarithm. And over here, the base is big, right, which it's now a little b in the logarithm. So the base and the exponent kind of switch being big and small. And the n, use right here, that it equals, just stays the same. Okay. So just practice a few of these going back and forth. So keep in mind that the answer is an exponent, right? And you can have this above right here, however you want to do it. So we have, this is the blue, if you want to keep the color coding going. Answer is the exponent, and 9 is our number. So just rearrange everything in the proper order. And of course, make sure it is truly equal. So 3 to the second equals 9, right? Over here we'd have, what is this? 6 to the third power is 216. And since we have a number that's a fraction, it's not a surprise that the exponent is a negative number. So recall that negative exponents are not negative numbers, right? They're just fractions, small numbers. And then, of course, we can go the other direction, right? We can take anything in exponential form, rewrite it in logarithmic form. So we'll have log for each one of these. We got our bases, 4, 2, 36. Got our numbers, 64, 32, and 6. And those are equal to the exponents. So the answer is always an exponent. So we got 3, 5, and a half. All right. Any clarifications needed anywhere here? Are we pretty good on this? Pretty solid? Okay. A little background for the base. It's always going to be a, let me go back to the right color. It's always going to be a positive number, bigger than 0. They can be decimals and things like that, but generally we keep it as a integer or a natural number, I guess, since it's bigger than 0. Right? Can't equal 1, because that'd be 1 to what power equals this, and well, 1 to any power would just be 1, so that would be a trivial number to have as a base, so we don't ever have that as a base. And the number over here that we're using is also positive, so you won't see any negatives on these numbers, right? They'll never have negatives there. Another little thing that if there is no log base. Like if it just says like 1,000, right? It's assumed without being written there. It's assumed to be 10, right? So if it's not there, it's automatically a 10. Okay. So, and then over here, let's see. Yeah, that's good. All right. So let's look at some problems on the back, and then get you guys started. So the most basic ones are just evaluating, basically get the exponent, right? So you want to start reading this. Log of 81 base 9. This is asking 9 to what power is 81? You're just, the answer is the exponent. That's it. So you get 2. All right. 3 to what power is 1 over 27? So first thing you should notice that since our answer is a fraction, our number is a fraction here, right? Automatically that means our answer is negative. Okay. So we have 3 to the third power is 27, so 3 to the negative third power would be 1 over 27. And then lastly we have log of 0.01, also known as log of 100th if you rewrite it as a fraction. Okay. So similar to B here, right? We have an assumed base of 10. You notice I didn't write the 10 in there because it's assumed to be 10 if it's not written there. So, but 10 to the second power is 100, so 10 to the negative second power is 1 over 100. So get really comfortable with the idea of having a negative answer here as an exponent without having any negatives in the problem, right? Let's see here. Why don't you guys try 5, 6, and 7? Do a few on your own. See how that goes. Okay. So we have negative 2. Since it's a fraction, we got a negative answer. Here we have 3, 10 to the third power. Easy way to do that is just count how many zeros are there if it's a base 10. So 3 zeros, power of 3. And then over here we got 7. This is asking 7 to what power is this? 7 to the 5th. So that makes the answer 5. 5. And you'll notice this and many other rules that we'll come across, that if these are ever matching the same exact thing, the answer is always the exponent. So you can use that as a shortcut. Okay. As long as those match, answer is the exponent. All right, so not too bad. Let's look at a few equations and we'll be done. So same thing, we can convert these to the exponential form. So we have, what here? The base is x, the exponent is 3, and that's going to be equal to 125. Now you could do two things. You could take the cube root of both sides mathematically, or you could just rewrite the other side as to the third power. So if you rewrite this as 5 to the third, then you're allowed to say, well, x to the third equals 5 to the third. Automatically you know that x equals 5. So that's another way of doing it. But if you just take the cube root, that's fine too. All right. Go ahead and try B. Give B a shot. And focus on writing the workout properly. Go. And if you want to continue down to 8, 9, and 10, you can do those as well. Just some good practice. And this last one, you could do it both ways, right? So we have a 3/2 power, which means we can do a square root of 9 and raise that to the 3rd power, like so. And if you try it the other way, it's still square root. You would just do 9 to the 3rd first. So even though there's 2 ways of writing this correctly, you probably want to choose this first way because it's a little bit easier to take the square root of 9 first and then raise that to the 3rd power and get 27. If you did it this way, it'd work, right? 9 times 9 times 9, I think it's like, what, 729 or something like that? Double check. Yep, 729. But the square root of 729 is not really known to us easily, so it is the same as 27 times 27. So you could take either way, but probably want to go down this method. So we get x equals 27. All right. So one little thing I'll throw out here because other people asked that we just finished a section or unit that said, well, if it's x to the 4th, how many solutions to this equation are there? There's 4 solutions, right? There's 2 real and there's 2 complex solutions, right? And you know how to find all those. Now all of a sudden we're just saying, hey, x just equals 3. When there's 4 solutions, we're just saying now we only have 1 solution all of a sudden. So pay attention to that and recall that we don't have the -3 because right here it said they had to be positive. So, but -3 is a solution because -3 to the 4th power does equal 81, right? And so we're not dealing with anything negative, and we're not dealing with anything complex. So of the 4 answers, we only need the 1. This is very similar to when you guys were solving Pythagorean theorem, and you had like 3, 4, and you had to find out what c is, and you went through, did the work, and you said square root of 25. Oh, that just equals 5. And we always ignored the -5. That also was an answer, right? So for the reasons, because there's a distance, we ignore the negative. Same thing here. We're ignoring some of the other possible answers because it doesn't work in logarithms if they're negative, and we're not doing complex logarithms yet. That's going to come down the road if you get into calculus and whatnot. All right, so just in case you're thinking about that. All right, so we're on homework number 34. Yep. Finish the other ones first. Make sure you don't have any questions. Check the back of the book for the odds to make sure you're doing them correctly. And use your time wisely for the rest of the class.